Blockchain technology is a decentralized and distributed ledger system that records transactions across multiple computers in a way that ensures the security, transparency, and immutability of data. It was originally designed to underpin digital cryptocurrencies like Bitcoin but has since found applications in various industries beyond finance. Here are key components and concepts related to blockchain technology. 1. Decentralization. Unlike traditional centralized databases, blockchain operates on a decentralized network of computers, nodes. Each node stores a copy of the entire blockchain, making it highly resilient to failures and tampering. 2. Distributed ledger. A blockchain is a continuously growing chain of blocks, where each block contains a list of transactions. The ledger is maintained simultaneously on all participating nodes, ensuring data consistency. 3. Cryptography. Blockchain uses cryptographic techniques to secure transactions and control access. Each participant has a public and private key, which helps ensure the integrity and confidentiality of data. 4. Consensus mechanisms. To validate and add new transactions to the blockchain, nodes must reach consensus. Common consensus mechanisms include proof of work, POW, and proof of stake, POS. 5. Immutability. Once a block is added to the blockchain, it's extremely difficult to alter or delete the data it contains. This immutability ensures a high level of trust in the system. 6. Transparency. All transactions are recorded on a public ledger, and anyone with access to the blockchain can view the transaction history. This transparency is a fundamental feature of blockchain. 7. Smart contracts. Blockchain platforms like Ethereum support smart contracts, self-executing contracts with the terms of the agreement directly written into code. They automate and enforce contractual agreements. Use cases. Blockchain technology has applications in various domains, including finance, for cross-border payments and digital currencies, supply chain management, tracking product origins, healthcare, patient records, and more. 9. Tokens and cryptocurrencies. Many blockchains have native cryptocurrencies or tokens used for various purposes within the network, such as fees, rewards, and governance. 10. Public versus private blockchains. Public blockchains are open to anyone, while private blockchains restrict access to a select group of participants. Each has its own use cases and implications. 11. Challenges. Blockchain technology faces challenges, including scalability, energy consumption in some POW systems, and regulatory concerns. Blockchain has the potential to transform industries by providing trust, security, and transparency in various applications. While it originated as the technology behind cryptocurrencies, its broader use cases and potential have made it a subject of significant interest and investment in the tech and business world.